Showtime!
Ladies and gentlemen, please make your way to your seats.
Showtime!
Please make your way to your seats. The show is about to begin.
Showtime!
Let the magic begin.
Welcome back to Futuretech, your weekly source for the latest in tech and innovation and business. I'm the startup coach, and as always, I'm joined by my co-host, John Irwin. How you doing today, John?
I'm doing good, Craig. I'm watching the Bitcoin halving countdown to 12 hours, 21 minutes, and 49 seconds. So we'll have to see.
What's happening then?
So the Bitcoin is having every 4 years, about 4 years.
Oh, okay, the halving. Sorry,
Yeah,
I missed that.
Or the halving, or whatever, however you want to pronounce it.
And I hear something too. I saw some in one of the newsletters I get that there's expecting it to go to 100K post halving. So we'll see how that goes.
People have predicted 100K last year, 100K 2 years ago, but I'm just, you know what? I'm curious to see what's going to happen this time. So is this the third halving? Fourth halving? I can't remember. Anyways, yeah. 12 hours, 77 blocks left. Current price, 65,000.
Yeah, let us know in the chat if you are into Bitcoin and what you think it's going to go to after the halving. Let's just say within 2 weeks after the halving. It'd be interesting. Mm-hmm. But we've got a lot to talk about. This first article is, if this is the one that first got up, it's not the one I first got up, but it's the one we're going to talk to first. Apparently,
that's why you're moving things around on me, but that's
I'm moving it around. We're going to talk about the Trillion-Transistor GPUs.
Yeah.
GPUs are all the rage. We saw that Sam, the guy from OpenAI, is going out and trying to raise, I think, $7 trillion to start a EFAB for a GPU company, specifically for API. We see all these major investments, and we see this Trillion-Transistor GPU. What's happening?
Well, makes sense. And just before we jump into it, there is a Canadian company, Grock, who was getting into the hardware, building a chip. And I think that they've pivoted. And now they've pivoted to more of a SaaS model. So it'll be interesting to see what Sam Altman does. Obviously, he's a lot further along and has a lot more collateral and clout. But Grock they did some really cool stuff. So right now, we pretty much only have NVIDIA, who can produce these massive or these amazing GPUs for AI and other complex problem solving. So the article itself provides a look into semiconductor innovations that are going to be needed to reach a 1 trillion transistor GPU within the next decade, which is critical to enable the next generation of AI capabilities. Not only that, the other issue we have, and sorry to go off on a tangent, but we need more training data as well to help with these AI capabilities. So that's another problem that we won't talk about now. But so it talks about key enablers that will be advanced, like 3D packaging methods like TSMC's CoWoS or SOIC, which allows stacking and connecting multiple chiplets. It overcomes the limits of conventional lithography-based manufacturing and can integrate systems with massive transistor counts. So what's equally important will be continuing device-level advances like new materials. So EUV lithography down to 1 nanometer and below, novel transistor architectures tailored for AI workloads. So the coordination of chiplet integration, system architecture, software optimization, and transistor improvements will drive energy-efficient performance. So the expansion beyond conventional 2D scaling into full 3D integration is pivotal for the revolution in the industry. It opens up architectural possibilities that we're only beginning to explore. So it's really cool, but in order for us to move forward, so we're talking about new transistor materials. So we're going to need new transistor materials and this gets into some stuff that we talked about before, nanosheets, nanowires, CFETs. That's going to enable scaling at smaller nodes that's required for high transistor densities. And now we're getting into Moore's law, right? And pushing Moore's law.
Well, hasn't Moore's law slowed down?
Yes, Moore's law has slowed down. But we were supposed to hit a limit, I think, at some point. I think this was years ago. And I think with the new technology that we're developing, so just for those that don't know, Moore's law states that the number of transistors on a microchip doubles about every 2 years, while the cost of computers halves. So in other words, the speed and capability of computers are expected to increase every couple of years, and we'll pay less for them. So it predicts that computers and machines that run on computers and computing power all become smaller, faster, and cheaper with time as transistors and integrated circuits become more efficient. So it's not a scientific law, but rather a projection based on historical trends. Obviously, this is based on silicon-based transistors and different things like that. But as we talk about different kind of materials and things like that, who knows if law is going to be broken or if it's still going to remain the same.
Yeah, this is interesting. I can see our need for it, and this is what we're talking about here, is that, our for example, training GPT-3, for example, required the equivalent of 5 billion operations per second of computational data for an entire day. So just imagine that.
Yeah, and the other thing too to note is that we talked about TSMC, and I could be wrong, but I think TSMC holds a monopoly over producing chips as far as the technology and the size. But it's crazy.
So where are we now? How long is it going to take us to get there to do this layering and get to, like we talked at the beginning of that Sam Altman's trying to open up this new GPU fab. What are we talking about here? Will he be able to be implementing this in a few years, or any of the companies, or is this something that's a little farther off?
So, in order for us to get there, there's a bunch of things that need. So the technology exists, right? This advanced 3D packaging, okay. But there's some key challenges that they need to overcome. So they need to overcome thermal management. So if you think about it, right now we do, well, for the most part, it's 2D kind of wafers, right? And so if you're stacking dies, if you're stacking these wafers, it leads to higher power density and localized hotspots that must be dissipated. So we're talking about taking a 2D model, changing it into a 3D model, a 2D model that already has like heat and power and issues, and then adding layers on top of that, right? So I don't think we're too far off. I would say maybe 2 to 5 years based on where we're at currently with the technology, as long as there's no big issues that come into play. But there's going to be, they're going to have to develop dense vertical interconnects between the stacked dies as well, while ensuring reliability and yield. There's mechanical stresses, there's die thinning, there's die-to-die alignment, again, supply chip maturity. There's a bunch of things that need to be overcome. So I don't think, I know we always say 5 to 10 years in most of these that we talk about, but I'm thinking we're 3 to 5.
Well, we're talking here about, silicon photonics, like we were talking about, I think it was last week, might have been the week before, when we were talking about the new internet speed breakthroughs going through optical fiber, packaging this kind of excess bandwidth right in together with the GPUs and the CPUs are going to allow it to scale up. What are, like right now, let's face it, the AI factories, yeah. The GPU houses where all this compute happens, that they call it, is very power intensive. If we take that up to the next level, and put a trillion transistors into the same data farms, what kind of power consumption are we have to scale to?
I honestly think we'll be, if like obviously at the start, they'll be more power hungry, but because there's more transistors, I think there's an opportunity to be more power efficient. It's just like when you have a bigger engine, right? If you want to go faster, yeah. So that's a bad example. Let's talk about this. But if you have more transistors available, there's likely potentially less power that could be used because you have a lot of different options, and it's not going to be maybe pushed as far as the current chips, if that makes sense.
Yeah. So when you're talking about stacking these things, at what nano level are we talking about? Like, the latest stuff from silicon from Apple's 3 nanometer, we were talking about 2 nanometer. Some of the stuff is 5 nanometer, 4 nanometer. We're talking about here. When we're talking about 3D stacking, are we talking about, 4 millimeter on 4 millimeter? Or what are we talking about?
I don't know. I didn't see that in the article, but I think there was something talking about 1 nanometer at one point. And so, again, so we're talking about a new technology, like a new chip design. So we might have to go to a larger wafer size at the beginning, and then get down to one nanometer. But who knows? The thing is right. All we're doing is we're stacking them on top of each other. We're stacking them dies on top of each other. So based on we could stack based on what the current size is, if that makes sense.
Yeah, I guess we're seeing a comparison here on the screen now for those who are watching, which is talking about the current where we're transistors per processors are currently increasing at 1.73 times every 2 years. And if we're using this chip-to-chip bond density technology to increase 1.74 every 2 years, you get to, what's this, 339, 786 billion on a per square meter versus 1,154.
Yeah. So I should correct that. To get to the 1 trillion is going to take a while, but to this 3D technology, I don't think we're far off. And you can see it here, even here, 2021, they've got 20,000 on one. So they're already starting to get there. They're already starting to produce them.
And to make a correction here, this right side happens to be apparently per processor, not per square millimeter. So we're not really comparing the two here.
Comparing apples to apples.
Yeah, let's just transistor count per processor, and then you've got trillion transistor per square millimeters. I guess it depends on how many processors you have that you start. Like this is saying, this is in the billions, 1,154.09 billion transistor count per processor.
Okay. So, that makes more sense. Yeah.
So this is very interesting. Okay, we're talking. Great. Here's some stuff on energy efficiency, because I was just kind of, we're always trying to make the environment a better place, and how do we not destroy it yet have all these wonderful things we want. Well, the increased energy efficiency performance threefold over the last 2 years, which is great. But I don't know. From low end processing, absolutely. The power saving modes of these new ARM technology and stuff is much better. But does that happen when your CPUs are running at full power?
No, and that's never gonna. But the thing is, and that's kind of where I was getting at. Thanks for that. Is you're gonna have obviously more transistors and to work through, and so lower power tasks are going to be more energy efficient on these chips, but they're going to be able to handle more power intensive tasks, which obviously they're going to be more power hungry than the current chips when you're using those tasks, because the current chips can't do those tasks, if that makes sense.
Yeah, and that leads us to this part where we're talking about this is a Meade-Conway moment for 3D integrated circuits. So for those of you who don't know, that was they designed the original CAD, the tools you needed to design the chips and stuff. And we're coming to that moment where we're going to need new tools to design these 3D chips, I guess.
Yeah.
to make this happen, and this is going to change everything.
For sure.
So it's on its way. An open source standard called 3D blocks apparently has already been embraced. So great.
Yeah. So again, this is with the current type of architecture, right? And so the thing that I'm curious about is, are there other architectures that could come into play and just disrupt this whole industry? Like, is there something completely that we haven't talked about, that we haven't explored, that could potential, and who knows?
There's always other stuff that could be happening, but I guess the question is, when we get to quantum computing, are they using these, or are they using completely different types of nanoscale hardware?
It's a good question. I don't even know what they're using for the quantum computing.
Because that feels like, as you'd like to describe quantum computing, is like it can all states at once and stuff. That's great. You would think that if it's capable of doing that, it would be capable of doing a lot more AI functionality than, say, a high-end CPU.
Absolutely. Yeah.
GPU.
The thing is so just based on my understanding, like, I know that quantum computers, they use specialized chips that are different from traditional classical computing chips. I don't know much more about them, but I think there's a bunch of different types of chip technology that are used, and they're proprietary built. So like IBM, Google, like they're all building their own proprietary chips for quantum computing.
And it's interesting. Oh, absolutely. Like, I haven't talked to any of them specifically. There are some interesting hardware companies in Canada dealing with quantum, but I've talked to a few of the ones that were related to a blockchain, that were building blockchain specific chips.
Oh, that's interesting.
Like Epic Blockchain and a few other companies. And this was back in the day. I don't know where they went, but they're either basically hardware to do the algorithm specifically, or to work with that are specific silicons designed specifically to work with the blockchain and make stuff work faster. So so all that stuff is interesting. I love where all this is going as we get more and more systems on a chip technology, and I think the world's starting to embrace moving away from an Intel CISC architecture and moving to like ARM. Seems to be what's happening now. We'll be seeing where that goes, and that ARM leads to all this more interesting system on a chip stuff, where you can do more specialized hardware, where the software is actually in the hardware.
Exactly.
So this becomes very, very interesting. Any last words before we move on to the next one?
Yeah, just to talk about the Canadian company Grock. So they develop specialized AI accelerators focused on inference workloads. So they've got a Grock chip architecture that they designed specifically for efficient deep learning computations like convolutional neural networks. So I know that they developed that, and now they're pivoting. But yeah, they've got, just talking about a cool Canadian company in this whole thing. So that has some promise. But yeah, that's it.
Do you know their website?
Groq.ai. Grock with a Q. Yeah.
There you go.
Not Elon Musk's Grock.
John, you help startups, technical companies, anybody with 2 developers or more find funding for their startups. What do you got going on, and what's the latest in startup funding?
Yeah, so there's a bunch of announcements made in the budget, so we'll have to see what comes out of that. I'm working on a summary right now, but yeah, I help companies across the board. I'm working with a agri company right now, and a bunch of others all across the board, clean energy, different things like that. So if you're a Canadian company, or even if you're not Canadian company, if you're incorporated in Canada, feel free to reach out. But yeah, that's I help with Shred is the best one to take advantage of, because you're entitled to it. It's a tax credit, but there's tons of other grants and potential funding out there. Non-dilutive funding, I must say.
And people should reach out to you on LinkedIn?
Absolutely, yeah. Send me a message on LinkedIn. I'll send you my Calendly, and we'll set up a call.
And you got anything going on next couple of weeks?
Other than Startup Drinks on May 2nd, I've got an actual, this is really cool, fractional C-suites and consultant private dinner put on by Ryan Wong, who's a phenomenal guy. That's coming up on Tuesday of next week. So I'm excited for that.
Yeah, you're supposed to send me these links ahead of time so I can pull them up for people.
I know. I just thought of it right now. I apologize. Yeah,
I know. I try to Google these things, but we go through. I know, same thing. Right, it's one of those things. That's great. Sounds wonderful. Do you know where they can find that? What do they Google?
That one's invite only, unfortunately. But that's but there's other ones that Ryan puts on that I will talk about as they come up. So yeah, there's some.
And we'll get links in there so we can find where it is. Check out all our stuff at TorontoStarts.com. That's where you get the Futuretech podcast that comes out. We're behind on releases, just so you know. We've actually got 42 episodes recorded, not including the 3 that'll come from this, because you mentioned that last week, and we've got like a 10 to be released that are all ready to go. I was slow releasing. I was doing 3 a week, and then I went to 1 a week when we switched my editing tool, so it took me a little while. But now I'm back. I know what I'm doing. Everything's good. So you'll see 3 episodes a week and maybe a little bit more as I'll start pumping them out until we get a little less of a buffer. So you'll see more of those. If you're stuck in your business and you're looking to move ahead, you're struggling with sales, finding clients, anything along that lines, go to startupcoach.ca, book a discovery call with me. We'll help you get unstuck and move to the next level. You mentioned on May 2nd, our Startup Drinks TO, we've got almost 50 tickets gone already. So it's going to be a great night. We're still just over 2 weeks away. Join us there. It's open bar, open pitch. You get 20 seconds to pitch. We have investors, founders, industry experts. It's a warm and welcoming environment. Everyone's going to give you advice and help you and connect. You always meet valuable connections, but it's not always what you think, the ones you think. And, I've talked to people as they're leaving. They found new business partners in this and that and the other thing. And it's always a great conversation. So hope to see you there. And we'll see you guys all next time on Futuretech.
Wow,